Got another batch of multiple choice questions for inorganic and physical chemistry. So this is number 8 now. I've got a separate playlist for organic chemistry. If you wanted to check that out, I'll put the link to that at the top of the screen now. As always, the link to the questions in the description of the video if you want to try them first. Okay, so the first question, we've got the 2p4 configuration for oxygen. Remember, when we put the electrons into the subshells, we have to half fill before pairing up. So the one that fits that is D, because this pair here have to be in opposite spin directions. So C was wrong because they're both pointing up. So D was the answer for that one. Moving on to number 2, nice and easy this one. So the anomalous properties of water are all down to the hydrogen bonds. So B was the answer. Moving on to number 3, so to calculate percentage atom economy, it's the MR of the desired product, so iron in this case, divided by the MR of all the products, or you could do of all the reactants there. And obviously to put it into a percentage, we multiply by 100. So there's all the answers, and you can see that option C has the highest percentage atom economy, so that's your answer. Number 4, obviously you need to know what an antacid is, so that's an indigestion remedy, so in other words something that's going to neutralise stomach acid, and the only option that can do that is B, the hydroxide. Moving on to number 5, so halogens exist as simple diatomic molecules, and they are held together by these weak London forces, weak intermolecular forces. So if you want to boil a halogen, you've got to overcome these intermolecular forces here. So the statement that reflects that is C. The induced dipole-dipole interactions, or London forces, become stronger as you go down the halogens group, because the more electrons in the molecule, the stronger the London forces get. Moving on to number 6, which equation does not represent a disproportionation reaction? So we're looking for the equation where you haven't got one atom being oxidized and reduced in the reaction. So to do that, we need to look for oxidation number changes, and there they are there. So you can see in A, chlorine has gone from 0 to +1 and -1, so that is disproportionation. Likewise in B. In C, it's gone from +5 to -1 and +7, so another disproportionation reaction. So D is the answer, because chlorine has been, well, nothing's happened to it there, but it's been oxidized up to 0 from -1 there, and then the manganese has been reduced from +4 to +2. So option D was the answer. Moving on to number 7, so the enthalpy change of neutralization is the enthalpy change per mole of water formed. So the first thing we've got to do is work out how many moles of water are going to form in this reaction. Well, we've got some information about the acid, and they were told that the potassium hydroxide is in excess. So the first thing we'll do is work out how many moles of acid that is, and then we can use the ratio to get how many moles of water would be formed. So moles of sulfuric acid, concentration times volume in decimeters cubed, so that many moles of acid we used, therefore twice as many moles of water is formed. Now we know that the energy released, given out, was 2.8 kilojoules for that many moles, so we just need to scale up to 1 mole. So all we do is divide the kilojoules by the moles of water, and we get 56, and because it's exothermic, it's -56. So the answer was A. Nice and easy for number 8. So catalysts decrease the activation energy, so we're ruling out C and D straight away, and it increases the proportion of molecules with energy greater than the activation energy. So the answer is B. Number 9 is all about an Arrhenius equation. So remember, the gradient in an Arrhenius plot is equal to -EA over R. So that means that -16,000 for the gradient is equal to -EA over 8.314. That's the R value. We'll get rid of those minus signs because there's one on each side. All we need to do now is multiply the gradient by the gas constant, 8.314. So the activation energy comes out at 133,024 joules per mole. Remember, the activation energy from an Arrhenius plot is measured in joules per mole, but we want our answer in kilojoules per mole. So it's not D, it's B. Number 10, so zero order means that the rate is unaffected, unchanged by change in concentration. So the graph that reflects that is D. Number 11, so equilibrium is reached when the rate of the forward reaction equals the rate of the reverse reaction and the concentrations of everything don't change. So the point on the graph where that's happening is here, point C. Number 12, any question about buffers, you need to be thinking acid over salt. That's my daft way of remembering the formula to calculate the H plus for a buffer solution. But you can see there's the chemicals needed for a buffer. So we've got the weak acid here. We need the salt of a weak acid, and that is A. That was sodium ethanoate. Number 13, testing our knowledge of qualitative analysis. So the first thing, we've got a green precipitate with sodium hydroxide. So that could be due to iron 2 hydroxide or chromium 3 hydroxide. So straight away we can see that C and D are in play. And that white precipitate with barium nitrate is barium sulfate. That's the test for the sulfate ion. So it must be option D, iron 2 sulfate. Number 14, which statements are correct about chlorine? It can gain 1 electron to form 1 minus ions. Yes, it does. Statement 2, it can lose its 3s2 electrons to form 2 plus ions. Well, no, because the 3s subshell is closer to the nucleus, so that's not going to happen. Statement 3, it can lose its 3p5 electrons to form 5 plus ions. No, that's not going to happen. So the only one that was right was number 1, so it's option D. And finally, number 15, which statements are correct about elements in the periodic table? The position of an element is determined by its relative atomic mass. No, that's wrong, because it's the proton number. Elements in the same group have similar chemical properties. Yep, that's right. Transition elements are used as catalysts. Yes, that's right. So 2 and 3 are correct, so option C.